More than 2 billion miles away, just beyond the orbit of Jupiter, is one of the most dramatic sights in the solar system. You've probably seen this image before. It's been called the most beautiful image of the year by some media outlets. And if you ask me, it really is breathtaking. This is 3I ATLAS. It's an icy visitor from the distant outer solar system that made its closest approach to the Sun on February 1st and then flew right by Earth in early March. This comet has given us some incredible views of what lies just beyond our cosmic neighborhood. And astronomers are eager to see what else it can teach us about the far reaches of our planetary system. On November 28, 2022, more than 3 billion miles from Earth, NASA's Jet Propulsion Laboratory began tracking a small, icy object hurtling through space towards the inner solar system. At first, the object was just another unknown passing visitor, like the thousands of asteroids and comets that whiz past our planet every year. But soon, astronomers realized this visitor was something special. It was moving much faster than any asteroid or comet ever recorded. And they soon realized that this fast-moving icy object would break all known records when it passed Earth's orbit. It would be the first comet to pass Earth's orbit in more than 50 years. And with that honor came renewed attention from astronomers around the world. They wanted to learn everything they could about this mysterious visitor and what it might tell us about the places of our solar system that we have never seen before. And so astronomers got to work naming the comet and tracking its trajectory. They gave it the official name 3IATLAS and began trying to determine where it came from and where it was headed. The answer to the first question would come first. Soon they were able to track its path back to the distant outer solar system where it likely originated. In fact, its orbit takes it further out than Pluto and then makes a loop around the Sun that extends as close as Earth's orbit and as far out as Saturn's orbit before turning back around and heading out into the farthest reaches of the solar system again. But the second question took a little longer to answer. For months, astronomers struggled to understand exactly where 3IATLAS would pass in relation to Earth's orbit. Its path had been hidden for centuries before it emerged from behind the Sun, and no one was sure if it would pass Earth's orbit safely, or if it would strike our planet or one of our neighbors. And those questions understandably caused some concern. After all, comets are responsible for some of the most devastating events in Earth's history. Most scientists believe that a comet impact triggered the mass extinction that wiped out Earth's dinosaurs 66 million years ago. And while a direct hit from 3I Atlas would not have been powerful enough to cause such devastation, astronomers wanted to know if it might still pose a threat to our planet. As the comet approached, researchers began scanning the sky for answers, and eventually they got the news they were waiting for. 3I Atlas would pass Earth's orbit just a few days after making its closest approach to the Sun on February 1, 2023. It would fly by our planet on February 5th, just a few days after its closest approach to the Sun. And that gave astronomers a once-in-a-lifetime opportunity. They would get a chance to observe a visitor from the outer solar system up close and personal, and they wouldn't have to wait long. So while astronomers worked hard to prepare their telescopes for what was to come, the rest of the world got ready to watch. Comet enthusiasts began training their backyard telescopes on the sky, and professional observatories prepared to capture stunning images and data about the approaching comet. Finally, the time had come. On February 1st, 3IATL has made its closest approach to the Sun, and several observatories captured this stunning view of the event. The surface of the Sun is just visible in the background, lending an eerie glow to the image and highlighting the comet's bright green coma. But unfortunately, this was the last time astronomers would get to see 3IATLAS up close for quite a while. As it turned and disappeared over the Sun, it became impossible to observe until it re-emerged from behind the Sun on February 5th. But when it did re-emerge, it wasn't alone. 3 days after passing the Sun, it was now flying by Earth, and it had company. A debris field nearly 500 feet across stretched across the sky beside it, leaving an unmistakable mark on the comet's journey. Now astronomers knew that 3I Atlas had released a significant amount of dust and gas as it approached the Sun. But they didn't expect to be able to see these particles in our sky. Yet here they were, lit up by the Sun and forming a line across the sky. This is a plume from the comet. It formed when 3I Atlas released huge amounts of gas and dust as it approached the Sun. But because the comet was moving so fast, the material didn't spread out as expected. Instead, it formed a solid line across the sky that remained there for days. Unfortunately, this is also the point in the comet's journey where it passed Earth's orbit and disappeared from view. Once again, it wouldn't be visible to anyone on Earth until it returned to the other side of the Sun more than 3 months later. But while it was gone, astronomers eagerly pored over the data they had collected, and what they found was fascinating. To begin with, they discovered that 3I Atlas was made of ice, specifically water ice. That wasn't surprising, since almost every comet discovered in the inner solar system is made of water ice. But they also discovered evidence of something else, something that suggested the comet had spent a lot of time outside of our planetary system before arriving. In the inner solar system, far from being a newcomer, 3I Atlas may have been traveling the solar system for hundreds of millions of years. To make sense of this discovery, let's take a look at the structure of a comet. Comets are made of rock, dust, and ice that have been brought together by gravity and formed into a solid mass. This is the comet's nucleus, and it is usually only a few miles across. Now, while a comet is flying through space, it looks like a small dark spot until it gets close to the Sun. Because as it approaches the Sun, the heat and radiation begin to take their toll on the comet. The gases and dust within it begin to evaporate, creating a cloud of gas and dust around the comet's nucleus. This is the comet's coma. Now, if the comet is moving fast enough, this coma can form a tail. And the faster the comet moves, the more material gets swept up in the tail and the farther it stretches behind the comet. And that's how comets work. But when astronomers studied 3I Atlas, they noticed that its coma and tail were unusually narrow, which meant that despite its relatively large size, 3I Atlas wasn't releasing very much gas and dust as it approached the Sun. And that suggested that it had already lost most of its volatile material long before it reached the inner solar system. In fact, it looked like the comet had lost more than half of its total mass already, which meant that 3I Atlas had been in deep space for hundreds of millions of years. If it had formed in the Kuiper belt like most comets do, it should have retained much more of its original mass. So astronomers believe that 3I Atlas is likely formed in the distant outer solar system where it remained stuck for billions of years before being kicked out of the solar system entirely. It traveled to the far reaches of interstellar space, where it picked up a thick layer of dust and gas. And when it finally returned to the solar system, it was unrecognizable from the comet that had formed in the Kuiper belt. Now, well, this discovery was exciting. It also meant that 3I Atlas wasn't going to teach us very much about the Kuiper belt. After all, that it spent so little time in the Kuiper belt, it wouldn't have had much time to pick up any unique features that could tell us about this distant region of our solar system. But luckily, 3I Atlas had one more surprise in store for us. When it passed Earth's orbit in March, it left behind a thin veil of dust and gas that covered the entire sky. And this veil contained clues about what 3I Atlas had seen on its journey through the solar system. Specifically, it revealed evidence that the comet had visited Saturn's orbit at least once during its travels. That's because the dust and gas that formed the veil matched the composition of Saturn's atmosphere almost perfectly. And it had been there long enough to pick up some of the unique material that Saturn is known for. And that suggests that 3I Atlas hasn't just been flying through the solar system, it's been exploring it too. During its travels, it's visited some of the most remote regions of our solar system and interacted with the unique environments there. And in doing so, it's left behind a trail of clues that astronomers are eager to follow up on. Now we won't get another chance to observe 3I Atlas up close until it returns to the inner solar system again in 2031. But thanks to the clues it left behind, astronomers will continue to study it for years to come. They will analyze the dust and gas it left behind to learn more about Saturn's atmosphere, and they will track its orbit to learn more about the outer solar system. Thanks to this comet, the next decade will bring some incredible discoveries about the farthest reaches of our solar system. 3.1. ATLAS may be a small comet made of ice and dust, but it's teaching us big lessons about the solar system and our place in it. And who knows what other secrets it might reveal in the years to come. Click here to learn more about Saturn's moon Titan, or click here to watch this video instead.